Hey there, Precalc. Here's our do now for today. See if you can factor these two and hit pause so you got that factored out. Okay, I'm unpaused. So let's see. First one, we're looking for two numbers that'll add together to get +6 and multiply to get +8. I listed all my factors, +8. Pick the two that are going to add to get 6, 4, and 2. And those are the numbers that go into my factors. So x plus 4 and x plus 2. Yay! Second one, I recognize as the difference of two squares. X squared, obviously, is a square, and 4 can be rewritten as 2 squared. And then subtraction. That's the difference. So easiest way, I want to recognize this is a difference of two squares. My two factors are going to be x plus 2 and x minus 2. Nice. Hey, so our goal for today is factoring trig expressions. But before we jump into factoring trig expressions, we're going to do some review about just factoring from an algebra perspective in general. It's a super important thing. It shows up like literally every single year of math. I mean, Algebra 1, geometry, it shows up once or twice. Algebra 2, I mean, it's like a whole unit of dealing with quadratics. And here it is again. Factoring is just one of the most powerful and useful things that we come across in high school math. So factoring, here we go. I'm going to jump back to this do now page and let's look at two additional problems. Go ahead and see if you can factor these ones, and then it's like this is the last part of the do now, but go ahead, factor these and hit pause. I'll wait. All right. Hey, so the first one, we could do the same thing that we did on the third one. We could do the same thing we did on the first one. Two numbers that'll add together to get +2 and multiply to get +1. My little list of factors, +1s and -1s. So I use the positive ones. So x plus 1 and x plus 1. And you probably notice those two factors are identical. This is a perfect square. So we can rewrite it as x plus 1 quantity squared. You don't have to, but that's where the name comes from. It is a perfect square. Number 4 is a little different approach. We've got a common factor, two terms. It could be any number of terms. This one has two terms. They both have a common factor. They both have a v in them. So this is like reverse distribution. It's like that's the answer to a distribution problem. We're going to write the original problem, and that's our approach to factoring. So we pull the v out, put that outside the parentheses, and then inside the parentheses, v squared minus 5. End of story. Super. Well, the big thing I got to point out here is that on each of these problems, the leading coefficient was 1. We didn't have it written in there, but every single one of these has a leading coefficient of 1. And when you've got a leading coefficient of 1, it makes the problem simpler to deal with. But what happens if it's not a leading coefficient of 1? Well, that is a great question. In order to answer that, let's back up a little bit. Let's do a quick review here about what multiplying binomials looks like. So if I need to multiply x plus 3 times 2x minus 5, there's lots of approaches. You might have learned FOIL, which is a fabulous approach, somewhat limited in its scope, but another approach is to use a factoring box or a multiplication box. I mean, they look the same. Multiplication box. So I'm going to take one of those expressions, x plus 3, and put it on one edge of the box. The 2x minus 5 I can put on the other edge of the box. You could switch them. It doesn't make any difference. I like the left and the top. Some people like to use the right-hand side. Don't use the left and the right. That wouldn't work, but they need to be on opposite axes. So anyway, the way we can multiply is it's like a little Punnett square. We just take the 2x and multiply it by the x. Put the answer into this box, so that'd be 2x squared. And then we'll move across, so 2x multiplied by 3, that'd be 6x. And then to the next row, that green x times -5 is going to be -5x. And the last one, -5 times +3 is -15. And then we can just string all of those terms together. And lastly, we're going to combine any like terms, which I have right here. +6x and -5x, those are like terms. So I can combine them. So I will get 2x squared. Positive 6 minus 5 is going to be positive 1. You don't have to write the 1. You could just put plus x equals 15. Okay, so we're going to, in factoring, we're going to reverse this process. So we're going to start with something like this purple answer we ended up at the bottom. This is a trinomial. Leading coefficient is not 1. So we're going to reverse this process to end up with 2 factors, like what this problem began from. Okay, so the only thing we need to pay attention to here is that the results, once simplified, had 3 terms, but when it comes out of our multiplication box, it had 4 terms, and we combined like terms. Okay, so that's the step we're going to need to reverse. We're going to have to take this middle term, the positive 1x or whatever it is, and break it apart into 2 pieces so that we have 4 terms. Those are the 4 terms that are going to go into the 4 parts of our box. All right, so how to do that? Here are the steps. I've broken them down into tiny steps, so it looks like there's a lot of them, but each of them is like super small. So if you start with a trinomial, like 2x squared minus 11x plus 12, I've color-coded this. First thing you're going to do, multiply the x squared coefficient and the constant, the yellow and the green together. And then you're going to make a list of all of the pairs of factors that would give you that number. Look through that list. Find which of those factors would add together to give you the blue x coefficient. That's what you're going to break apart, that middle term. So our original problem had 3 terms. We're going to break the middle term apart into 2 pieces to give us 4 terms total instead. Step 4, put those 4 parts inside the 4 box. And then step 5, we're going to factor to get the numbers that go on the outside of the box. Those are the factors. And then finally, number 6, write our answer in fact. All right, first example, 2x squared plus 7x plus 3. All those terms are positive, so this will be a little bit easier on the first example. So first step, multiply that yellow x squared coefficient by the green constant, so 2 times 3, that is 6. I'm going to make a list over here to the side, and then I'm going to, below the 6, I'm going to list all the possible numbers that I could multiply together to get 6, including negatives. A lot of times we forget those. And then we're like, I'm stuck, I can't figure it out. And it's like, well, yeah, we got to think about the negatives too. So then once we have completed our list of all the different things that will multiply to give us 6, we're going to go back through here and identify which pair in that list would add together to make that blue x coefficient of positive 7. So if I add these two together, it is not positive 7, not positive 7. Yay, that's it. 1 plus 6, that'll give me positive 7. So I'm going to take the 1 and the 6 and use them to split apart the plus 7x in that original expression. So 2x squared is going to stay put. The plus 3 is going to stay put. And I'm going to break apart that 7x into 2 pieces, plus 1x and plus 6x. So this is mathematically equivalent to the original. 1x plus 6x is the same thing as 7x, but now I have 4 terms. So I can fit those 4 terms into my factor box. It'll fit all 4 spaces in the factor box so that I can factor, right? So the x squared term always goes in the upper left. The constant always goes in the upper right. Those 2 center terms are interchangeable. I'm going to fill them in, the 1x up there and the 6x down here. And then we're going to look across the rows. You can do rows or columns first. I'm going to look across this first row and see what is the greatest common factor. So 2x squared and positive 1x, they both have x in common. And then that red x would have to multiply by what mystery number in that green circle to equal 2x squared as an answer? Well, you'd need x multiplied by 2x. And then I'm going to move my mystery circle. Okay, that red x multiplied by what mystery number is going to give me that blue positive 1x as an answer? X multiplied by positive 1 is going to give me the positive 1x. All right. Let's move that mystery circle back over here. All right, so the green 2x multiplied by what mystery number in that red circle would give me an answer of the blue positive 6x. 2x times what equals 6x? So this is going to have to be positive 3. So my final answers, the factors, those two green ones go together. That's one factor. So 2x plus 1 goes inside one set of parentheses. And those two red ones, the x plus 3, that is my other factor. Final answer. Doesn't matter which order you write your two factors. I put the green one first and then the red. You can switch them around. Doesn't matter. All right. Okay, next example, negative 3x squared minus 10x plus 8. And so we'll notice, first of all, that leading coefficient is negative. So if you have a negative leading coefficient, my recommendation is we're going to factor out a negative 1 to start. So we're going to have positive 3x squared plus 10x minus 8. And I'm going to bring these colors down here. Okay, so if we factor that negative 1 out, we've just created one of the factors. So we're going to have negative 1 as part of our final answer, negative 1 times, and then we don't know what the rest of the factorization will be yet. But that negative 1 is going to be part of our final answer. So we've created like a distribution problem, right? So the common factor we factor out of negative 1. Okay, do that first so that we have a positive leading coefficient to work through the rest of the process. You don't have to, but it does work a lot nicer this way. So I'm going to take the yellow coefficient, that 3, and multiply by the green constant. And 3 times negative 8 is negative 24. So I'm going to make my list of factors over here to the side. All right, so negative 24, and I've already written down all of my factor pairs just to save a little bit of time. I always start with 1. It's easy to forget the ones. We start with 1, and I just work my way, you can see on this left column, work my way up from 1s, negative 1, 2, and negative 2, 3, 4. And then the last one I would have negative 4 and positive 6. If I was to keep going with this list after 4, obviously comes 5. 5 is not a multiple of 24. The next number is 6. And 6 always already appears in that list, so I know I have covered all the possible factors, right? When once I hit repeats, I've got them all. Okay, so next I'm going to go through this list, and instead of multiplying, now I'm going to add. So I want to see which of these factor pairs will add to make the blue coefficient on the x, so negative 10. Inside the parentheses, we're using positive 10. So positive 10, 1 plus negative 24. Nope. No. Almost. 2 plus negative 12. That would give me negative 10. But now I am looking for positive 10. So it's going to be this one, negative 2, positive 12. Okay, so this negative 1, I'm not doing anything with it, but it is part of my answer. So I'm just going to leave it there. It's going to come along for the ride until I get the rest of this worked out. So the middle term, that positive 10x, I am breaking apart into these two pieces, negative 2x, positive 12x. And so now inside the parentheses, I have 4 terms. Those 4 terms go into the factor box. The negative 1 that I've already factored out does not appear at any point in the factor box. I've already identified that as a factor. So it just hangs out in the meantime while I finish factoring the rest of the problem, and then it'll show up as part of my final answer again. So 3x squared in the upper left, negative 2x, positive 12x, and negative 8. And the negative 8's got to go down there in the bottom right. All right, so let's look across this top row. Greatest common factor for 3x squared and negative 2x is going to be an x. Mystery number here, that red x inside the circle, x multiplied by what would give me that answer of 3x squared? That's going to be a 3x. Move my mystery number circle. That red circled x multiplied by what equals negative 2x? And I'm going to need a negative 2. All right. Move that red circle down here. So the green 3x multiplied by that red mystery number needs to multiply together to equal 12x. And so this one I need to multiply by 4. Lastly, let's just double check. Those two circled numbers should multiply to give me that bottom right-hand corner. The red +4, the green -2. If I multiply them, I do get -8. I always like to double check just to make sure I didn't make a mistake someplace. So there are all my factors worked out. So I've got that -1 that I factored out back at the beginning. And then I'm going to do the green one first. So 3x minus 2. And then the red one's x. And that's a +4. So I need to write in the plus sign here. And there's my final factored form.